Welcome all to a session on Big Data Analytics. In today's session, we will look into one of the chapters of Module 4, which is Artificial Neural Network. Artificial Neural Network is a concept or a topic from deep learning, right? Which is one of the segments of machine learning. So you might have already heard the terms like artificial neural network, convolution neural network. All these are the topics that are under deep learning, and today we will be looking into artificial neural network. And unfortunately, in the syllabus we don't have any problems to solve with respect to artificial neural network, but we are going to see how the artificial neural network works. Okay, only the essence or a gist of the working of ANN. So let us see. This is not definition. This is more like an introduction to artificial neural network. ANN or artificial neural network are inspired by the information processing model of the brain. So this neuron is a term that is biological rather than a technical term. Okay, so our brain consists of billions of neurons, and this human brains, what it does is, with the billions of neurons that link with one another in some intricate pattern, every neuron receives information from many other neurons, and it processes it and decides whether the information is very useful or whether it is very exciting or not. Okay, and if the information is very useful and um, if the information is towards the likingness of that particular neuron, it processes it and it passes its state information to the other neurons. So basically these billions of neurons will be working together by by processing information and passing it to solve many complex problems, to pass the judgment, to predict certain events. Okay, so this is how human brains work, with respect to neurons. And what we are going to do is, using the concept of human brain, which has billions of neurons, we will be using artificial neurons to solve problems. Okay, so with this is inspired, as it is mentioned here, it is inspired by the information processing model of the brain. Okay, so using that model, we will technically, rather than biologically, we will be technically creating a neurons to solve the problem. So let us see how it works. Yeah, so this diagram shows the two interconnected brain cells or neurons. Okay, so it will be having something called as axons, so through which it passes the information to other neurons. Okay, so this is how it works, and our human brain is having billions of such neurons. And artificial neural network is a black box, so it will be act as a black box where we pass inputs and it will give the output. Okay, and this artificial neural network has the ability to learn by itself. We'll see how it learns in detail. Okay, so first let us see some of the business applications of ANN. Neural networks are used most often when the objective function is complex and where there exists plenty of data and the model is expected to improve over the period of time. And some of the sample applications are a stock price prediction. So this is a classical regression problem, right, where we need to predict the stock prices, where the rules of the games are extremely complicated and a lot of data need to be processed very quickly. So other example would be character recognition. So this is again this is an image processing problem, where we make use of convolution neural networks to recognize handwritten text or damaged or mangled text, and they are used in recognizing fingerprints as well as used to detect face detection. It's also used in face detection and such kind of problems. Then the other one is a traditional classification problem. For example, deciding whether to approve the financial loan application, or to, yeah, it's, in other words, deciding whether to give loan or not to the applicant, or deciding whether a patient is having a heart disease or not. Okay, so such kind of classification problem, either it can be binary or categorical. So apart from this, it is also used to solve problems of association analysis and also clustering. So it is having plenty, it's a very powerful model. It has a lot of applications. So this is about the business application of ANN. Okay, now let us look into the working of an ANN. So these, the diagram which we will be looking, which comes up in the slides, are not available in the textbook. Okay, so these are not part of the textbook. In textbook, they have given a small introduction to ANN, which we will be looking again later. So before that, let us see the working of an ANN, how the ANN works, and how it learns from itself, learn by itself. Okay, so this is artificial neuron here, which is also called as perceptron, which computes which does the processing, and it takes input from various sources from other neurons. Okay, so the input signal is passed to this neuron, and it does some processing, and it gives the output signal to another neuron, or to the output layer. Okay, another hidden layer, or to the output layer directly. Okay, so this is how the structure of the neuron is, or the basic working of a neuron. Okay, it receives input from various sources and gives the output signal to the next neuron, and this gives a better understanding of the working of an artificial neural network, where I have a single neuron here, but in reality I'll be having multiple hidden layers, which again, which we'll be looking very soon. Okay, so this is how um, a neuron or artificial neural network works. Okay, where I have a single neuron, which is also called as perceptrons, and here x1, x2, and xm are the input values. So these are the dependent values. Okay, these are, sorry, rather independent values, input. So these are the independent values, and x1, x2 up to xm. Okay, so these are the independent variable values, from which I have to predict the output value y. Okay, so very similar to the machine learning concept, what we have already learned, right? Very similar to classification, regression, and other machine learning problems. Okay, so what we do is we pass this input to the neuron, and the neuron does the processing, and it gives the output value. But it does not accept only the input, it also takes some weights. Okay, this plays a major role in self learning of the artificial neural network. Weights are the very significant parameters in deciding, or in the working of a artificial neural network. So each input is assigned some weight. Okay, and along with the input, the weight is also passed to the neural network as a signal. And our neural network has two functionalities. One is summarization, sigma, and the other one is transformation. So what it does, what is summarization is, let us see. Summarization is I is equal to 1 to m. Okay, so this, what it does is, it calculates the product of the weight and the input value, and adds it up. Okay, adds it up. So this will give a summation. Okay, so x1 into w1 plus x2 into w2, x3 into w3, so on up to xm into wm. So this is what we do, summarization. We add up the product of the input value and its weight. Okay, and weight can vary depending on the working of a neuron. Okay, and these values will be changed as per the requirement. Okay, so once um, the artificial neuron or a neuron, if it calculates this summation value through and this is called as summarization function. Okay, then comes transformation. So what is transformation? See, the summarized value will not be passed to the next neuron or to the output layer. So what happens is this summarized value will be converted into some other value using the transformation function. So what transformation function does is it takes the input from the summarized value, it transforms the value into some new value, okay, using the transformation function, using transformation function. So the output of the transformation function will be passed out as an output. Okay, so which are the various transformation functions used? The most commonly used transformation function is threshold function. Then I have sigmoid function. Then there is rectifier function. Then there is hyperbolic tangent function, okay, or hyperbolic function. So let us see each one of these. So what we do is, okay, so in the y-axis I have the predicted value which is either 0 or 1, okay, and on the x-axis I have this summation value or the summarization value 1 to m xi wi. So in thresholding what happens is for a particular value, let me say it as 0, okay, so 0 in the sense if the summarization value ranges from negative to positive, okay, if I take 0, then see, after performing summarization on a particular input, if the value uh, turns out to be somewhere positive, maybe for example 0.5, okay, if 0.5 is greater than 0, right, so this will be acting as a threshold. So any value greater than this threshold value will be converted to 1, okay, converted into 1. So that will be sent as a transferred value, and anything less than 0 will be converted to 0, and that will be sent to the next neuron or as an output signal. Okay, so this is very simple. There exists a threshold value. So if the value is above the threshold value, the summarized value is above the threshold value, it will be converted to 1. If not, it will be converted to 0. So this is how the transformation function for thresholding works. Okay, similarly for sigmoid it is very similar to thresholding, but the curve here is not very, you know, it is a little smoother when compared to the thresholding. Okay, so here you have a strict value, isn't it? After 0, anything above 0, you have the y value as 1, and anything below that is 0. So but when it comes to sigmoid, you have more smoother curve, something like this. Okay, so this is 0, a smoother curve, you will be having more smoother curve. And yeah, so this equation, transformation equation, will be equal to 1 by 1 plus e to the power minus x, where x is the, so this in, yeah, this is as same as the previous one, up to m xi w. Okay, so this x is nothing but the input value. So this is the sigmoid function. Okay, so we have seen 2, and fine, then comes rectilinear. So this is also something like this. So if you have 0, I is equal to 1 to m wi into xi. So here I have y. So this is also again, this is there is no sudden change, rather you'll be having a slope, something like this, in a rectilinear function, and the transformation is max of 0 comma x. Okay, and hyperbolic, finally the hyperbolic function. So this will be useful if the value of the output ranges from -1 to positive. Okay, -1 to positive, and here I have 0. So this is again the summation xi wi up to m. So this is very similar to the sigmoid function, but the value range is from -1 to +1. Okay, and the transformation function is equal to 1 plus e to the power minus 2x divided by, or rather 1 minus here, divided by 1 plus e to the power minus 2x. Okay. So this is the hyperbolic tangent function. So these are the various famous commonly used transformation function. Of course there are more than this, but these are some of the most prominent and regularly used transformation function. Okay. So this is about the general working of neuron. Now let us consider some example. See here I have the house prediction or house price prediction. Okay, so these are the input. So these are the input. So I have the input layer here, and I have the output layer which need to be predicted. So the price of this house need to be predicted based on this independent variables. So I have x1, x2, x3 and x4. x1 is the area, bedrooms, distance from the city, then age. Now what I will do is I will add the hidden layer. Okay, so these are the neurons. So I can have multiple hidden layers, but here I'll be using only one, and these are the neurons. Okay, so which will be receiving input from the input layer, does the processing, perform the transformation and gives the output to the output layer. Okay, so let us examine each of these neurons. Okay, so I have considered this particular example. First let us look into this particular neuron. So here it is taking input from x1 and x3, right? x1 and x3. So this is very useful. See, when predicting the house, area and distance from the city matters, right? See, if you go out of the city, if you go further from the city, you will get a bigger house for the same rate or for the same price what you would have got in a place which is very close to the city, isn't it? You'll get, for the same price you'll get a bigger house area. So this particular neuron is only looking for such kind of data. Okay, because that will have a huge impact in determining the price of the house. So it will be scanning for the house which is having which is near to the city and is having a higher area, right? So such kind of data it is looking for, and it will have a huge impact in determining the price. So this is concentrating only on these two particular input value. So some weight will be assigned to it, right? Okay, so higher weight will be given to the area and the distance. So what you can do is you can consider the weight for bedroom and age as 0. Okay, then coming to this particular neuron, so here it will take input from x1, which is the area, then bedroom and also age. So here this is a common criteria, right? Some may prefer, some may not be bothered about the house that is where it is located, right? It doesn't matter whether it is far or near to the city, but what they want is a big house, preferably a big house with plenty of bedrooms. If the family is having if the family is big, or if they have a lot of children, then they prefer a house with bigger bedrooms or more number of bedrooms and a bigger area, and also they prefer house which is very new, right? That is a very young house, very newly constructed house. So this is these three plays a major role again in determining the price. And coming to the last layer, okay, so price, age. So this will be looking only into age. So it is taking input only from the fourth input layer, that is age. Now what we can say about age? See, if the newly constructed home is, or house is obviously having a higher price, isn't it? Well, that is a common, that's a common sense, right? A new house is having a higher price, but the older it gets, it will lose the price. It will the price value, market value will reduce. But what if the house is more than 100 years? So in that case, this house will be having some historical value, right? It is very very ancient, and that will be having a very high value, right? So the age of the house will determine the price in a multiple ways, right? If it is new, then it will be having a very high price. Then if it is little older, maybe around 50 years, it is not having a great price. But again, if the house is more than 100 years, so that I can I can see as a threshold value 100, then it is having a very high price. Maybe some old ancient structures are used, or some old wooden pillars are used to construct the house, right? So this layer is concentrating only on that. Then comes this particular neuron, which takes input from bedrooms and a distance from the city. So something that doesn't make sense for us, right? But this can be some of the um, a parameter, a major parameter. A bedroom and distance from the city can be some of the parameters to decide the price of the house. And this particular neuron is taking input from all the four input layers. So it is considering equal, or it is giving equal or more importance to all, or equal importance to all the four input layer. Okay, so what this yeah, so this is how the neurons are structured, or how it is weighing the input. Okay, then what it does, it takes the input, it it performs the transformation, passes the input or passes the output to the output layer, and the output layer should be able to predict the price. So this is how a neural network work. Okay. Very simple, right? Okay, but let us now see in detail how the neural network learn from itself. Okay, so consider this particular diagram. I've kept a single neuron just to keep things very simple. So here I have weights and input, right? So this is the input layer, independent, which is the independent variables, and using these weights, the neuron weights and the input, it will does the processing, does the summarization, does the transformation, and it gives the output value. And this output value is represented as y hat. Why it is y hat? Y hat represents the predicted value, isn't it? The calculated value by this model, and it is not the actual value. So we have actual value also, right? So this y hat is something that is predicted, or that is the output what is obtained from the model, and we have the actual value, which is y. Now we have to see whether the predicted value is similar or very close to the actual value. So that is determined. Okay, so this is the y hat value, this is the predicted value, and this is the actual value. As you can see, it is not very close, right? So we need some metric to find the difference. So that is nothing but the cost function. So using the cost function C, which is, this is a very simple cost function. Of course, there are multiple formulas. So which is the square difference between the predicted and actual value divided by 2. So half of the squared difference between the predicted and actual value. Okay, output value and actual value. So as you can see, I am having a very high C value, so which is not good. The C value should be very small, because see, as the difference get smaller, the C value gets smaller, right? And if the predicted and actual value is equal, the C value will be equal to 0. So that is the ideal solution what we want, but normally that is something is not achievable. We will not be able to get the C value as 0. So that is very difficult. Okay, now let us see what happens. So this is the scenario what I have. Now the output layer, it will compute the cost value, and it gives it back to the neuron, saying that this is the cost value. You have to adjust or you have to do something, you have to learn and do the better prediction. Now only way the neuron can adjust its processing is not by changing the input value, but by changing the weights. Okay, so what it does, what this neuron does is it takes the input, it takes the feedback rather. Okay, so this is the back propagation. It takes the feedback and it changes the parameter, weight parameters. So it may changes, it may give more value to the W2, it may reduce W1 or so on, whatever, right? It learns. So it does thing, this uh, parameters are changed, and after changing the parameter, it again gives the does the processing and gives the output. Okay, so here after performing the changes, so this is the new value that is obtained. Now you can see I have a better solution than the previous one. So the previous solution was this one, right? Now I have a better solution. It is very closer to y. Previously it was very far, the difference was very big. Now again the c value is computed, the c value has largely decreased, but it is not an ideal solution. I am not satisfied with my solution, right? But still I have some differences. So again the feedback will be sent, again the neuron will adjust the weight. Okay, after adjusting the weight, what it does the processing again. Now it has given me or predicted the output value y hat is equal to y. So in this case the c value is equal to 0, right? So this is the ideal solution that is required. So this is how the neural network basically works. Okay, so it does the processing, compares the output with the actual value. If it is not satisfied, it goes back again and adjust the parameter, weight parameters, then it will obtain the output. Okay, so this is how the basic working of neural network. Of course there are plenty more questions to be asked, like whether it has to be done on each and every record, or how this feedback system works, right? So let us not look into let us not go very deep into this. So this is the basic working of an ANN. Okay, then of course to determine the c value we have various functions like stochastic gradient descent and gradient descent and stochastic gradient descent, which is out of or beyond the scope of this particular topic in for our syllabus. Okay, so coming to the textbook explanation, so this is the design principle of an ANN. As I said, have independent variable x, okay, which is having some weights, and this is the neuron structure which does two operations, summarization and transformation. So this is something what I've already explained, and this is the model of multi-layer ANN. Okay, so the same thing, whatever that is explained, where I kept the shape of the neuron as circle, but here it is represented as a rectangle with the two functions here, summarization and transformation. So this is the diagram what you can find in the textbook. Okay, coming to architecting a neural network. Okay, anyways, these are again not a part. These terms are not in the textbook. I mean, you don't have this in the syllabus, but you just have to remember what kind of architecture are used for different problem statement. For classification, I make use of for feed forward networks, radial basis functions, and probabilistic. And for regression, we make use of only feed forward networks and radial basis function. Probabilistic is not used. And for clustering, we make use of adaptive resonance theory and self-organizing maps. And for association rule, we make use of hoppified networks. Okay, so anyways, these are again beyond the scope of this syllabus. You just have to remember these terms, or remember this architecture that is used for these kind of applications. Okay, so this is again comes in depth in deep learning. Okay, anyways, we are not gonna go into in depth of this artificial neural network. We just have to remember that these are the various functions or architectures that is used for the various type of problems. Now let us look into the various steps in developing an artificial neural network, which is very similar. I mean, these are some of the common steps that we have encountered, that we encounter in any machine learning problem statement, right? So first thing what we do is we gather the data, which is very much required, because we need a lot of data for artificial neural network to work, and we divide the data into training data and test data, and the training data need to be again further divided into training data and validation data. So in some application in some approach we don't make use of validation data, we directly make use of training data, but as in a few of the application, again the training data is divided into training data as well as for, and the data is reserved for validation. Okay, so that we call that as a validation data. Anyways, we'll see this in the next slide. Then we have to select the network architecture, such as a feed forward network, or the other other networks as mentioned here, based on the application or based on the problem statement what we have. After that, we have to select the algorithm, such as multi-layer perception, or again we have a single layer perception also. So such kind of algorithm we can offer with respect to ANN we can choose, again, which is beyond the scope of this topic, okay, beyond the scope of the syllabus rather. So we have to select an algorithm. Then we have to select the network parameters, such as assigning the weights and selecting the transformation function, etc. Then we have to train the ANN with the training data, validate the model with validation data, and then we have to freeze the weight and other parameters. Then we have to test the trained network with the test data. So these are some of the common the step 5, 6, 7, 8 are the common steps that we follow in any of the machine learning techniques, right? Okay, first we train, we validate, and then we perform, we deploy the model on the test data. Okay, then we deploy the ANN when it achieves a very good predictive accuracy. So these are the steps of deploying an ANN. Okay, coming to the data sets what I spoke about. So normally we make use of the concept of 70-30, right? 70% is for the training data and 30 for the test data, but sometimes you can see 60-20-20. So 60 for the training data, 20 for the validation data, and 20 for training data. Again, that depends on the programmer or the architect who is going to design an artificial neural network. Normally we will go with only training and test data. Okay, yeah. So what is the validation set? Validation set is used to minimize the overfitting, and it is used to verify the accuracy of the data. Okay, then 20% again we make use of 20% of the data as a test data. Then we may also make use of k-fold cross validation function. So what is this cross validation function? So this training and test data is again cross validated. We divided it into some k folds, and we perform k number of times training and testing, okay, or training the data k number of times. So with the diagram I'll explain. Yeah, so this is a k-fold cross validation. In this k is a an arbitrary value which decides the number of times I have to perform validation. Okay, so here the k value is 4. Okay, so what happens, 4 times I have to perform the validation. So what we do is we divide the entire training set into 4 parts. So in round 1, this P1 part, okay, suppose if I have 100 data, 100 is the amount of data. Out of 100, 80 will be the training data and 20 will be the test data, right? So initially P1, this part will be considered as a test data. I'll be performing training here on these 3, P2, P3 and P4. And in the second round, of course, I'll get some accuracy. Let us consider it as 80. Okay, then in the second round again I will choose P2 as a test data. Then on the remaining P1, P2 and P3 and P4, I'll perform the training. So I'll train the model based on these data, that is P1, P3 and P4. assume that I get 90% accuracy. Okay, then comes round 3, so where I make use of P3 as the test data, and P4, P1 and P2 will be used as training. So assume that I get 85%. Then finally, if here in round 4 I make use of P1, P2, P3 as training data, and P4 will be used as a test data. Okay, so this will be the test data. So I assume that I get again something like 85. Okay, 85%. Now, why this is required? Why this is required? Why cross validation is required? See, this takes a lot of time, isn't it? It's a very time consuming operation. So this, let me explain why it is required. See, if I perform a single round of training and test data, I may get in my training set, if I am very lucky, I may get a very good set of training data, right? So which may give me a very good efficiency, right? But it is in reality that might not be the case. I just got very lucky with my training data, such that, see, if you get a very good training data, obviously your model will be good, and if you apply the if you give the test data to the training to the model, your accuracy will obviously it will be good, right? Suppose that, see, just consider, assume that I have given this as round 2, whatever I got here, this as the training data. Okay, this as the training data, and this P2 as the test data, and my accuracy whatever I obtained is 90%. So I may think my model is very good, that it is 90% efficient, but reality is that I'm just got very lucky with the split, right? My training data and the test data split what I had is very good, right? So this will be having a lot of bias. So instead of this, if I do cross validation, then as you can see here, I got 80, then 90, 85, 85. So if I have to obtain a total predictive, or if I have to conclude, then what I have to do is I have to add these, okay, and divide it with the k value. So here it is 4. So how much I'll get? I'll get 85%. So in reality, my model is not actually 90% accurate, it is rather 85. Okay, so this is the usefulness of k-fold cross validation. Now let us see the advantages and disadvantages of artificial neural network. So let us see the advantages first. The first one is ANN impose a very little restrictions on their use. So this is the greatest advantages of ANN. ANN can deal with any type of problems, like I can deal with the classification, I can deal with clustering, I can deal with the regression, and also association analysis. So it is having a very little restriction, right? So this is the greatest advantages of ANN, and ANN can also deal with highly non-linear relationship on their own without much work. Okay, without much work from the user or the analyst. Second one is, there is no need to program neural network as they learn from example. So this is again, there is a very little input from the, or programming part is very less, as the neural network learns from itself. Okay, so this is again one of the biggest advantage of neural network, and they can handle a variety of problem types. As I have already mentioned, it can handle classification with the binary classification, as well as classification that has categorical value. Then it can handle regression, it can handle association analysis, and also clustering. ANNs are tolerant of data quality issues. This is again another advantage, and as I have already mentioned, they can handle both numerical as well as categorical variable, and ANNs can be much faster when compared with other techniques. And most importantly, they usually provide better result prediction and clustering compared to the statistical counterparts, and once they have been trained enough. Okay, there is also some disadvantages. One is they are deemed to be black box solution. This is something what I've already explained, right? So it is considered as a black box solution lacking explainability. Thus they are very difficult to communicate about um, except through the strength of their result. Okay. And optimal design of an ANN is still an art. It requires great expertise and extensive experimentation, especially in deciding these parameters of weight, and also deciding the algorithm, and also deciding the number of hidden layers and the neurons. Okay, so it is an art, and it requires a lot of expertise, and it could be difficult to handle a large number of variables. So this is also a problem or disadvantage of an ANN, especially um, the rich nominal attributes. And finally, it takes a large data sets to train an ANN. So that is one of the major disadvantage. I require a large data set to train an ANN. Okay, so the larger the data set, the better will be the model. Okay, so these are some of the advantages and disadvantages of ANN. So with this, I conclude this particular chapter of artificial neural network. I'll see you all in the next one. Bye.